Now let us see the problem under splitting the region of integration. So first let us draw the region of integration. So the region of integration is, let us consider x-axis and y-axis. This is x-axis and this is y-axis. So first y is equal to 0 is the x-axis. We can draw these two lines later. So here x equal to y square. X equal to y square will be a parabola like this. Okay, so this is the parabola x square is equal to, y square is equal to x, or x equal to y square. Now this is the line, it will be like this, which passes through 2, 0 as well as 0, 2. So this is the line x plus y is equal to 2. Now we need to consider this intersection point. So by solving these two equations, we come to know the point is 1, 1. So why we are marking this is easy to draw the line y is equal to 1. So y is equal to 1 should pass us through this point. So this is the line y is equal to 1. And the region bounded by all these four equations are, this is the region. Clear? So this is the region which is bounded by the x-axis and the line and parabola and y is equal to 1. Now let us identify the limits. So while identifying the limits, here it is given dy dx. Suppose according to the same order, if we are taking the limit for y first and then for x, we have to consider a vertical strip for y-axis, y limit. So if you consider a vertical strip like this, the limit varies from where? Varies from 0 to upper limit touches the parabola. So y is equal to root x we have to write. Clear? And what about x limit? While moving this strip from this throughout the region from left to right, it reaches till x is equal to 2 and it starts from x is equal to 0, that is from the origin. And before that, what I am checking here is, if I take a strip over here, what will be the limit for y? What will be the limit for y here at this particular region? Y varies from 0 to, it touches the straight line x is equal to x plus y is equal to 2. From this y is equal to 2 minus x. The region is a single region, but two different limits we are getting for same variable y. So if you come across such a situation, then we have to split this region. So that is the name given here as splitting the region of integration. So at which point we have to split this region? See the intersection point, that is where the limit gets changes. Only at the intersection point the limit get changes. So towards the left of this line, it has the limit 0 to root x. Similarly, right of this region, it has 0 to 2 minus x. So at this intersection point, you have to split the region and consider this region as D1, okay, D1, and this region as D2. So these are the limits for the region D1 and these are the limits for the region D2. Now like this we should have two separate limits for y itself. Similarly for x we have to check. For region D1, how x ranges? So this point is what? 1. X takes the value 1 here. So x, this is the origin 0, 0, and this is the point 1, 0, and this is the point 2, 0. Right? So now x varies from 0 to 1 and then only 1 to 2. So here x takes the limit 0 to 1 and here x takes the limit 1 to 2. So this is the way for a single problem for same double integration. Here we are having two different limits. So what we can do here is, based on these two different limits, we can write the integration as two different integrals. So how to write it? So now this question, double integral xy dy dx, can be splitted as sum of two integrals. This is the limits for the region D1 and this is for the limits for the region D2, limits for the region D2. Now we have to integrate as usual the two integrals separately, and then we can get the answer. So first let us start with the first integral. Integrating with respect to y, x is kept as constant, so y square by 2, 0 to root x dx. Similarly here 1 to 2, here again x, y square by 2, the limits are 0 to 2 minus x dx. Suppose if you feel difficult to do it simultaneously, first you can evaluate d1 and then separately evaluate d2 and then finally can add it. So here I am doing simultaneous together. So 0 to 1, here x into y square is root x whole square is x again by 2, lower limit is 0, plus here 1 to 2, again x into 2 minus x whole square by 2 dx. So this we have to simplify. 0 to 1, this becomes x square by 2 dx, plus integral 1 to 2. If you want we can take 1 by 2 outside. So x into this becomes 4 minus 4x plus x square, right? So now after integration we get x cube by 6, because x square integration is x cube by 3, already 2 is here, and then taking 1 by 2 common, then multiplying by this x inside and then integrating it, we get the answer like this. Then applying the limit for the first term, we have to take the limit as 0 to 1. For the second term we have to take the limit as 1 to 2. So here upper limit is 2, lower limit is 1, so upper limit minus lower limit you have to substitute. So this gives you 1 by 6 here, plus 1 by 2 into, here it is 2 into 4 minus 4 into 8 by 3, plus here it becomes 2 power 4. 2 power 4 by 4 will give you 4 again. So this is upper limit minus lower limit is 2 minus 4 by 3 plus 1 by 4. So after simplifying this, finally we get the answer as 3 by 8. So this is the answer for the integration.